Hello there! This video is going to cover the basics and provide some examples of descriptive, correlational, and non-experimental research strategies. Or really, research strategies that involve measurement, not manipulation. If you look at the example here on the screen, you can't manipulate the number of children ethically, right? So number of children would be more of a quasi-independent variable that's not manipulated, and then we could also measure number of missed classes to see if there's a relationship there. But again, nothing is manipulated, just observing and measuring how things occur naturally. So while this lecture is largely focused on correlational research, and I'll give you several examples of that, I'm also going to give an overview and example of the descriptive research strategy and the non-experimental research strategy. So descriptive research is focused on one variable. Now you may have multiple levels of that one variable, like you see here in the example, but it's focused on looking at one variable. And typically, descriptive research focuses on frequencies. So how many people fit in each category of this variable, or how many observations fit in each category of this variable. So we see here in the example, they've got the number of students, and that would be a frequency. So how many students preferred each type of food vendor on campus. Sometimes you see descriptive statistics and descriptive research as well. So like the central tendency, mean, median, or mode, or measures of variability like the standard deviation and standard range. So we could look at the average number of students per day who went to each of these different types of restaurants. But we're still only looking at one variable, the different types of restaurants. And then we're just counting how many times that variable occurred in our data. So for our stats nerds, if you're examining the statistical significance of differences in frequencies specifically, a chi-square test for goodness of fit is usually best. So here's an example of some hypotheses. So like you see here, you could have a hypothesis that says there's a significant difference in the number of students who prefer each restaurant at the student center. I actually ran a chi-square with this, and I got a very, very, very low p-value that was 0.14 zeros and then 6.3. So almost impossible that this distribution would have happened if there was no real difference in preference. So we know that these differences here aren't just due to sampling error or random differences. Specifically, if we dig down into these results, these descriptive research results, we can see that students preferred Starbucks significantly more than the others, and they preferred Firehouse Subs and the dining hall significantly less than the others. So some other examples of a hypothesis that would be fitting for descriptive research could be that there are more females than males in a class, significantly more, or students taking a statistics class, that's our sample, will tend to prefer in-person and virtual classes more than they prefer asynchronous online classes. So in that case, the variable would be the type of class, right? Also, another example could be students tend to text more while studying and attending class than they text while driving. So we're just looking at how often they're texting and the frequency in different situations, which would be our variable. Now let's spend some time focusing on correlational research. That is probably the most popular research strategy in behavioral sciences, and there's also some limitations to consider when it comes to correlation research. So correlational research is all about looking to see if there's a relationship between variables. And with a correlation analysis, you only look at two variables at a time, but with a regression analysis, you can look at many. So we're looking at the relationship that naturally exists, naturally occurs between variables. Nothing's being manipulated. We're literally just measuring two things at the same time to see if they are related to each other. So for instance, my hypothesis could be that students who sleep more tend to have a higher GPA, right? I'm not manipulating hours slept. I'm just measuring those two things. I can make this more experimental if I actually manipulated sleep hours and had different conditions, but that's not what's happening in correlational research. So you can collect data on these variables through surveys or through a behavioral observation, or even by looking at old pre-existing archival data. Please keep in mind that correlation is not causation. There's a lot of reasons why that is, but please just keep in mind that results from correlational research should not imply that one thing causes another. Sometimes correlational research is the only option that we have because it's unethical or unreasonable or just not feasible to manipulate conditions, and we just have to measure how things are related. But take those results with a grain of salt. If you look at a correlational research study and they base their hypotheses on well-tested past theories and past research, and they get similar to results that was found in the past, that can be pretty good evidence that there is a causal thing happening, but you would need to do a follow-up experimental research study to confirm causality. So let's take a look at an example of correlational research looking at who is texting in class. So the method section of the journal article is where you would go to figure out how things were measured in the study, how things were operationalized. And the variables of most interest here are cell phone intrusive thoughts and cell phone use. So I love that they gave some sample items, right? So these items, when I receive a new text message or phone call, I feel the need to interrupt what I'm doing in order to read the message or take the call, right? That's one of the items. And you can see the other items there. They also tell you that they rated it on a 5-point Likert scale from strongly disagree to strongly agree. And you can see that higher scores indicated more intrusive thoughts about someone's cell phone. They also looked at cell phone use. So they estimated the total number of text messages sent and received, the total number of phone calls made and received during a typical day in the past week. And they asked them about their use of texting in a bunch of different contexts. So while studying, while attending class, and while driving a car. And they measured these also on a 5-point Likert scale. So you can see how these variables were operationalized for this correlational observational research. They didn't put them in different contexts. They didn't manipulate anything. They just measured how things occur naturally. So if the researchers hadn't looked at intrusive thoughts about texting, and they literally just looked at how often people are texting in different contexts, this would have been descriptive research. So here you can see our descriptive frequencies, right? You can see that on average, people sent about 4 texts while studying, about 3.5 texts while attending class, and about 2.5 texts while driving. So you can see that results suggest that students tend to text more while studying and attending class than they do while they are driving. And again, this would be a descriptive study if we only looked at that one variable, the context of texting behavior. So here's our correlation matrix with the results of how all the variables are related. And remember, each number represents one pair of variables. So right here, this is variable 2 and variable 1. So we can see the stars, right? Significant. We got those low p-values. That there is a significant relationship between texting in class and texting while studying. And it's positive. So if you remember from the correlation overview, that means that we have a consistent upward pattern such that those who text more in class tend to text more while studying. Those who text less during class tend to text less during studying. Here, if we want to just look at the demographics section and look at age, we can see that age is only significantly related to texting in class. None of these other correlations have stars. And because it's negative, we know that older people tend to text less in class and younger people tend to text more in class. And remember, all of these variables were collected through self-report. Nothing was manipulated. If we go further down in the correlation table, you can see that CPITS, or cell phone intrusive thought scale, that scale we saw in the measure section, was significantly correlated with just about all the other variables. So if we look here, you can see that those who had more intrusive thoughts were texting more while studying, texting more in class, texting more while driving, texting more during the day, right, across the board, because you see those stars and you see that they're all positive correlations. Now let's take a look at non-experimental research, which is sort of similar to correlational research because it involves 2 variables or multiple variables at a time, but it's not something where the two variables are measured in a numeric way. So non-experimental research is like a quasi-experiment with pre-existing groups, but there's no direct manipulation or intervention from a researcher. You're just examining differences in the dependent variable, or criterion, between groups representing each pre-existing level of the quasi-independent variable, or the predictor. So an example hypothesis, if you look at the table, could be instead of looking at the number of students who prefer each food vendor on campus, like the descriptive research with one variable being preferred food, this example of non-experimental research examines two variables by examining differences in customer satisfaction, which is our dependent variable, operationalized as mean Google review ratings in the past 3 months. And we're looking at differences in those Google review ratings that measure our dependent variable of customer satisfaction between food vendors on campus. And those different food vendors represent the different levels of our quasi-independent variable, our food vendor. Based on actual reviews for Marshall University food vendors that you see in the table, there's no significant difference in customer satisfaction. But overall, Chick-fil-A and Steak and Shake have slightly higher ratings. So here are some other examples of a hypothesis that you could have for non-experimental research. Seniors tend to miss more class than freshmen, sophomores, juniors, and seniors, right? You're comparing pre-existing groups based on class standing. That's your quasi-independent variable. And you're looking at another variable, how often they miss classes. That's your dependent variable. Another hypothesis could be psychology majors tend to visit office hours more than business majors. So you're looking at two different variables, office hours attendance and major. Major being probably your quasi-independent variable and office hours attendance being your dependent variable. Another example, graduate students tend to experience higher levels of schoolwork overload than undergraduate students. Graduate student or undergraduate student would be 2 levels of student status, your quasi-independent variable. Then your dependent variable would be schoolwork overload. Another one, supervisors tend to experience more stress than subordinates. So again, 2 variables, stress and work status. And our work status would be supervisor versus subordinate. That's our quasi-independent variable. And our dependent variable would be more stress. And I'll actually show you an example of a study that's looking at the stress and supervisors versus subordinates in the next example. For my stats nerds out there, typically an ANOVA, or analysis of variance, is used to analyze this data because you can usually compare means from interval or ratio variables across those nominal levels or categories of your quasi-independent variable. If you only had 2 levels of your quasi-independent variables, if you were just looking at like Chick-fil-A and Steak and Shake, you could use a t-test for independent samples to analyze that data. So here is a sample page from the Organizational Climate Survey that I ran at Nevada State. And what I did in this page is I looked at differences in specific types of workplace stressors between non-supervisors and supervisors. Most of these were measured on a 1 to 7 scale. So you can see that overall, if you look at the means, pretty low levels of stress overall, which was very exciting findings. So if you look at the means, they're all relatively low, around 2 or 3, which is low on a 7-point scale. But you can still see that there are differences. And I indicated significant differences by putting bold if they are significant. So you can see variables with significant, alpha equals 0.05, which basically means that P had to be less than 0.05. Those are bold. So you can see there was significantly, and also there's the highest one is underlined. So I think that helps with the interpretation. So you can kind of see a summary of the findings down here. So supervisors tend to report higher levels of workplace stressors overall. You see more underlines, right, in the supervisor means. And many of the differences were statistically significant. So our supervisors reported higher levels of difficulty doing their job because of lack of policies, confusing procedures, red tape, increasing work demands, and work overload. And if you look overall, work overload, which is at the bottom, had the highest means overall and a much higher mean for supervisors than non-supervisors. This is non-experimental research because we are measuring all these different variables, looking at stress, but we're just comparing pre-existing groups, supervisors and non-supervisors. So here are some more results comparing supervisors and non-supervisors in the Organizational Climate Survey. And here we're looking at diversity climate, fairness, support, and job-related attitudes. So in this case, for most of these, you want higher scores if it's measuring something positive and lower scores if it's measuring something negative. So you can see overall that supervisors tended to report significantly higher levels of support for tasks and responsibilities. They tended to be more satisfied with their employment contracts. They also reported significantly lower levels of satisfaction with diversity climate and fulfillment of diversity commitments. So it looks like our supervisors aren't feeling as great about diversity climate. and they had significantly higher levels of exhaustion, which makes sense because in the previous table we saw they also had significantly higher levels of work overload. So again, non-experimental, comparing mean values of a variable across different levels that were pre-existing. So I'm going to conclude this video by giving you an opportunity to think about it. So take a look at this example, read through it, and try to see if you can figure out the independent and dependent variable and the type of sampling strategy, which would be review from previous lecture videos. Also thinking about the type of methodology that was used and what type of data collection method was used, which is also review from previous videos. And then just think on your own, what are some of the limitations of Tahara's sampling strategy and data collection method that make it more difficult to make strong conclusions? So pause this video, read through this, and try to answer these on your own before you hear my answers. Okay, so hopefully you tried this on your own. So in this example, Tahara is Tahara is actually my advisor from grad school in Tahara Probst, and she's fantastic. And this is actually the type of work that she does, so I had to use her as an example. But anyway, Tahara wants to examine the impact of job insecurity on underreporting of accidents among construction workers. So she's going to look at self-disclosed, right, self-reported, unreported accidents between various construction companies, or two construction companies. One has impending layoffs, and the other one doesn't. So the results suggest that Company A with impending layoffs had more underreporting than Company Z, and she concluded that job insecurity is going to lead to more underreporting. Maybe they're afraid if they report, they'll be on the chopping block. So in this case, your independent variable is actually a quasi-independent variable, and it is the level of job insecurity, which is operationalized as impending layoffs or not impending layoffs. So we didn't manipulate impending layoffs or not. We relied on pre-existing groups that had or didn't have those impending layoffs. Our dependent variable is the accident reporting behaviors, so the level of underreporting. The sampling strategy was probably convenience. Tahara probably had access to these two construction companies. She works in Washington State, so they were probably located in Washington State or Oregon or Idaho, somewhere near there. And just so happened that one had impending layoffs and one didn't. So I would guess this is a convenience sample. The research methodology here, which is most relevant to this lecture and what we covered, is non-experimental research. The two companies were pre-existing. Nothing was manipulated, and participants were not randomly assigned to job and security conditions. So the type of data collection method that was used was a survey, because you can see they said self-disclosed, right? Another alternative would be observational research, where especially if you had AI and some surveillance technology, you could monitor near misses in the workplace and count how many of those happened. And if you were able to use facial recognition technology to know who it was, then you could do a survey and you could measure all sorts of things to see if they're related to that. May not be ethical, though, to surveil that much, but that would be an alternate way to do it other than a survey or self-disclosure. So thinking about some of the limitations of having a convenient sample and having a survey study, some of the things could be that would, influence the ability to make strong conclusions would be inaccurate recall. So it's really difficult to methodologically control for pre-existing differences in safety climate between the organizations as well. So they may not be able to recall their past behaviors. Did they have near misses? Did they not report? And it's hard to look at differences in safety climate. There's also many different factors that contribute to underreporting, like supervisor reactions to reporting, that could already differ between the two companies and have absolutely nothing to do with job insecurity or impending layoffs. It's nice that Tahara only focused on construction companies, but there's still going to be differences between those two companies that have nothing to do with impending layoffs that could result in differences in job insecurity. All right. So I hope having an opportunity to practice it helps solidify your understanding of non-experimental research and all the pieces of the research methods that lead to it. And you feel capable of looking at other people's research and evaluating if it's correlational, non-experimental, or descriptive, and that you know that these type of research studies do not lend themselves to causal inferences, or in other words, cause-effect types of conclusions. Again, if you do replication and you start to see similar findings, you can become more confident that there's a cause and effect, right? That job insecurity is what leads to differences in underreporting, but experimental research is the best strategy.